crap, you're already here. Well, thanks for coming. Wow, focus directrix form of a graphing, a parabola. Could anything get more exciting? Perhaps watching paint dry? Watching grass grow? No. We are NK Infinity. I always say we infinity, and I've had people comment the fact that who is the we person in this thing? You know, there's just me standing here. I guess we is me, that's K, my partner in crime, N, and you. You are part of our infinite group of fans. By the way, the infinity again stands for how long a math class generally takes. Oh my gosh. I should be on America's Most Talent. With jokes like that, I'd just kill everybody. Or I'd put them to sleep. My name is Mr. Key for the next half an hour. Actually, this one's going to take a little while. Now, listen. I'm going to do more examples than your teacher can get through, or if you're a teacher, that you could get through in a classroom. Pick and choose. Make sure you understand which ones that you're going to give to your students. Students, if you're doing it right now, or you're working through this right now, you can't get through all these in a class, but make sure that you do a good mix of these and try these and get a good handle of them. They're not all done the same way. Sometimes I give you the low focus. Sometimes I give focus and director. Sometimes I give you the focus and vertex. Sometimes I give you the vertex and the locus, or the focus. Sometimes I give you the vertex and the directrix. So you got to play around with it and see what you're going. And some of you are like going, what the heck is he talking about? You'll get there. By the end of this, you'll know what a focus is, what a directrix is, and what a vertex is. Oh, you already know what a vertex is? You're like 1/3 of the way there. Okay, maybe 1/10. So in geometry last year, I know for some of you that brings up shivers. Oh my God, geometry was so much tough. I'm agreeing with you. Geometry's a little tough. It's a little weird. Kind of get your brain to think a little bit differently. But you learn what a locus of points were. When you did all your constructions, you know, it says, draw the locus of points equal distance from two rays, blah, 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 whatever it was. So you learn that a locus is a collection of points that satisfies a given condition. You did that last year. So what I would like, and if you can pause this if you would like, if you'd want to, try on this to draw the locus of points that are 5 units from the point -3, 2. So you can pause it if you want. Oh, welcome back. Thanks for coming back. Well, the first thing we're going to do is plot this point -3, 2. There it is right there. Now, if I give you a point, and I say go equal distance from it, and I want you to go 5 units. You go, oh, okay, I'll go 5 units over there. I'm there, and then you go 5 units, and then you go 5 units, and 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 you go 5 units. It's like having a string, or, you know, this is like having a dog, I hate to say this, a dog tied in his yard with a thing that rotates, and he can just run around in circles and circles and circles and circles. Please don't do that to your dog. If you're doing that to your dog, you're just tormenting them, really, because that just frustrates a dog to no end. Play with your dog. I love my dog. I should have my dog down here. He's probably upstairs going, where's my daddy? 1, 2, 3, 4, 5. He's a big dog, though. I got a big dog, and I got a little dog. 1, 2, 3, 4, 5. Little dog barks at everything. 1, 2, 3, 4, 5. Yesterday saw a leaf drop. He was protecting us from that leaf. Oh, yeah. It's a dachshund. 2, 4, 5. He is a wiener dog. So this is the locus of points equal distance from the point -3. Now I said describe this. So normally when you see the words describe, you can say it is a circle. It is a circle with radius 5 centered at -3, 2. Excuse me, but I also like the equation, or want the equation as well. And the equation of this circle is, do you remember how to do this? So it's x and x. And remember, when you put the center in, it's +3 and -2. So it's x plus 3 squared plus x, not x. Ooh, that was embarrassing. Y, minus 2 squared equals, and over here goes the radius squared, so 25. And hopefully that's above my bald head right now. Sorry, coffee was calling me. So that's the locus of points. Okay, you learned that last year. So now let me give you the locus definition of a parabola. Yes, there is a locus definition of a parabola. A parabola is a locus. Let me do this in a different color. Red. A locus of points equidistant from a fixed point known as the focus and a fixed line known as the directrix. So a locus of, the definition of a parabola using locus is a parabola is a locus of points equidistant from the focus and a directrix. So, wow, these things didn't appear in the right place. So anyway, this should be pointing at this 0, 2. Hopefully it does on yours. And so it says on the graph the points, all the points equal distance from 0, 2 and the x-axis. Well, 0, 2 would be the focus, and the x-axis would be the directrix. So I come over to my graph, and I said, okay, the point 0, 2 is right here. In the directrix, I'm going to draw in with a green line because it's the x-axis. So this is the directrix. So I need, and I'm going to do in light blue, I'll do it in green, no, dark blue. I need all the points that are equal distance from that red point and that green line. Well, clearly this point is equal distance, right? It's right in the middle. That's equal distance. If I go over 2 and they're down 2, that's equal distance. And if I go over 2 this way, and that's equal distance. Now you're starting to see the parabola, right? You're starting to see it. I think this point is, what is that point? 1, 2, 3, 4, up. 1, 2, 3, 4, 5. Yes. So, yeah, that point is, and so is this point. Now, you wouldn't know this exactly that those points would be, and then that's 1, 2, 3, 4, 5, and also this point. So if you plot these points, in class I would go over these points, and you wouldn't know why these points are, but here I'm going to show it to you. There's my parabola. So this distance is 2, and this distance is 2. This distance here is 5, and this distance here would also be 5. I should be doing these in a different color. So this distance here, from here to here, and from here to here is equal distance, both 5. So that's the parabola. So how far is the vertex? Well, obviously then this is the vertex, right? How far is it from the focus and the directrix? Well, it's 1 unit. And then I said use the distance formula to show that the point 610 is equal distance from the focus and the directrix. Well, here's the point 610. I put it up here. Now, let's do the easy part. The distance from the directrix is always the easy. There's always an easy and there's always a hard. But we're going to do the easy part first. How far away is this point from this line down here? In other words, what is this distance? Well, didn't I go up 10? So that distance is 10. Now, the hard part is to figure out what this distance is. Now, if I did things correctly, that distance should also be 10. But I'm going to use the distance formula, and if you don't remember it, because you forgot all about geometry, the distance formula is D equals the, oh no, this doggone thing's coming back, x2 minus x1 squared plus y2 minus y1 squared. There it is. So let's do that. So the point is 610. and the focus was 0, 2. So we say the distance is equal to, we'll subtract the x's, 6 minus 0 squared, plus subtract the y's, 10 minus 2 squared. Yes, that's a 2. So this gives me the distance is equal to the square root of 6 squared plus 8 squared, which is equal to, let's see, 6 squared is 36, 8 squared is 64. That would be the square root of 100, which is equal to 10. So yes, the distances are the same. This is 10, and this is 10. So they are, in fact, the same. So what I've drawn here is the locus of points equal distance from the focus and the directrix. We're going to talk a lot more about it. That's a good English. So good for me. All right, so let's take a look at an example. Determine the equation of this parabola. So I want you to be able to tell me the equation of this parabola is y equals, and I don't know. So we know that the focus, I'm telling you that the focus is right here at 0, 3. There's the focus. And the directrix I'll draw in red. Thought I switched to red. Direct focus I'll draw in red, the directrix. So this is the directrix. All right, so let's take a look. Does that point look like that point looks like it's 2 away, and this point looks like it's 2 away, and this point looks like it's 2 away, and this point looks like it's 2 away. Any other good points? Oh, here's another good point. This point is 1, 2, 3, 4, 5 away. And this point here is 1, 2, 3, 4, 5 away. 5. But is this 5? I don't know if this is 5. I don't know. I can't tell. That's on a diagonal. Now, I could mathematically do that, and I will eventually. But what the directions say and what you're going to get used to doing is picking a general point. So drawing the focus and directrix, I've done it. Label a point. Any point anywhere on the parabola, but what I'm going to ask you to do is not pick a nice point. I'm going to pick this point maybe right here. I'm going to call it X, Y. Any point on the graph, call it X, Y. All right. So let me see if I can go up a little bit. Now write an expression for the distance from the point xy to the directrix. So let's take a look at what this is. Here's the point xy, and I'm going to go down. Now, would you all agree that there thing is the distance from this point to the directrix? Now, I want something that will represent what that means. That distance is equal to, well, the y value here, let's take an easy point. What would this distance be? This distance here would be 2, but that point is 1, 2, 3. So how do I get that distance of 2? Now, I'm picking any generic point because I want to, but we know that this line right here is the line y equals 1. So couldn't I take this y value and subtract off the directrix in order to get that distance? In other words, this distance here is 3. This distance here is 1. 3 minus 1 is 2, and that ends up being what's left over here. Well, that's what I want to do here. I shouldn't have done dotted line there, a pain in the neck to get rid of. This distance from here to here is actually y units. This distance from here to here is, oh, excuse me, not that one. This distance from here to here is 1 unit because this is the line y equals 1. Therefore, if I just take this part right here, I just want this part right here. That part right there is y minus 1. That's the distance y minus 1. We're going to do this a bunch of times, so get used to it. So that's the easy part. Finding the distance between the point and the directrix, this is the easy one. The distance is equal to, it's always y minus the directrix. Y minus directrix. All right, so this one's a little bit harder one. Now I want to find, let me get rid of all this extra crap. Now I want to find the distance and I'll do it in green, from the focus to this point. Well, that one is the harder one, and that one you have to use the the distance formula. So our 2 points are x, y, and the focus, which was 0, 3. I remember, is it 0, 3? Focus 0, 3. So we want to use the distance formula between those 2 points. So, okay, so we're going to say, okay, the distance is equal to the square root, subtract the x's, x minus 0 squared, subtract the y's, y minus 3 squared. Now, if this is truly a parabola, well-drawn parabola, this distance here, which is what we call d, and this distance here, which is what we call d, those two things have to be equal to each other, because that's the definition of a parabola when we're doing focus directrix, that the distance from the point to the directrix and the distance from the point to the focus have to be equal to each other. So if we've got two things that represent d here, this distance and this distance have to be equal to each other, and that's where the really hard work comes in. This is where the really hard work comes in. This is where you're going to earn your money, kids. Okay, I just stopped and I just saved it, and I just take a look at the piece that I just saved. And for some reason there was about a minute or two there where my head was all fuzzy. I hope you all enjoyed that fuzzy head talking. I have no idea why that happened, but since it was so cool, I'm going to leave it and not reshoot it. I thought it was kind of cool. Some fuzzy bald guy talking to me. So here's where we're going to earn our money. Let's go back and look what we got. We've got d equal to y minus 1. That was the first one. That was the easy one. And we also have d equal to the square root. Now I'm going to simplify this just a little bit. X minus 0 is just x. So that's x squared plus y minus 3 squared. So apply the definition of the parabola. The definition of the parabola is the distance from the point to the directrix and the point to the focus have to be equal to each other. And we're going to do this and we're going to solve for y. So we're going to set these two things equal to each other. This equal to this. And this is where the really hard work comes in from. So we're going to set y minus 1 equal to the square root of x squared plus y minus 3 squared. All right. So you should have remembered from way back when, how do you get rid of a square root? You have to remember to square it. So if I square the right side, I have to square the left side. The left side squared is y minus 1 times y minus 1 equals, now the square and the square root cancel each other out, so I'm left with x squared plus y minus 3 squared, which is really just y minus 3 times y minus 3. So once you've done that, then we got a little bit double distributing and then a little crazy cleanup to do. No problem. So let's do a little crazy double distributing. Now I'm not going to go through all of this. This is y squared minus y, so that's minus 2y plus 1 is equal to x squared plus y squared minus 3y is minus 6y plus 9. Now if you've done this correctly, the y squareds should eliminate each other. So, because if you subtracted this y squared, it would cancel with this y squared. In other words, they're the same thing on both sides. So if we lift them off, the equation is still balanced. So it does want you to solve for y. So what we're going to do is we're going to add this 6y. And we're going to add this 6y. And so what we get is 4y equals, oops, excuse me, I forgot the 1. Lots of places to make mistakes. 4y plus 1 is equal to x squared plus 9. We're almost done. We're going to subtract 1. Subtract 1. So I end up with 4y equals x squared plus 8. Now we're finally going to do that last step here. We're going to divide by 4, and I get y equals, now you can leave it like this, x squared plus 8 over 4, but that's also equivalent to 1/4 x squared. That's, remember there's a 1 here, 1/4 x squared plus 2. Now would you agree with me, if I just had this without the plus 2, that would be a parabola that hit the origin. But this parabola moved up and 2 units. So now that's my new vertex. That's why it's plus 2 at the end. And it's wide, right? So it's 1/4, so it's wide. So there it is, kids. There's the equation. This equation would give you that parabola. That was fun. What is the translation that takes place from the graph that we had in 1? Now, what you didn't know is, I don't think I gave it to you, the graph in 1 was 1/4 x plus 1 to this one in 2. The only difference is from 1/4 x squared plus 1 to go to 1/4 x squared plus 2, this is just a translation up 1 unit. That's it. How did we go from the last one to this one? It's just a translation up 1 unit. You ready to rock and roll? Let's talk about the pieces one more time. There's a picture of what you need to know. This is the focus directrix definition of a parabola. The definition of a parabola in focus directrix form says you have a locus of points. That's the parabola part, this locus of points. Equal distance from the directrix and the focus. So what that's saying is these two distances, let's call this D and this D, have to be equal to each other. D equals D. That's why I got the little tick marks, right, back in geometry. Those two line segments are equal to each other. Axis of symmetry is the perpendicular line that to the directrix that passes through the focus and the vertex. That's this axis of symmetry drawn right here. The vertex is the point where the axis of symmetry intersects the parabola. It's also called the turning point. That's right here. And finally, the focus and directrix, the point and line that all points of the parabola are equal distance from. Okay? Just get in the habit of knowing what these things are called. Where's the focus? Where's the directrix? Where's the vertex? You need to know directrix, vertex, focus. And the only thing I don't like about this drawing, and it's probably the way I stretched it, is this distance here should be equal to this distance here. So probably I need to drop that line just a little bit. This distance should be equal to this distance. And it's not quite, so it's not a perfect picture, but it was hard to create. Gosh, give me a break. Ain't nothing better. Oh, nailed that commercial. Gosh. All right, here we go. So here oops. Always moves when I don't want it to, and doesn't move when I do want it to. Okay, so we got this. Just a quick drawing. Pick a different colors, a couple different colors. This, let's pick a point right here. Any point on the parabola, this distance has to be equal to this distance. Doesn't quite look right. This distance has to be equal to this distance. It looks better on the paper I did. I wonder why. Let me do a different color here. This distance has to be equal to this distance. Any point you pick, these two distances have to be the same. This one looks a little off. I don't know why. Hopefully this one's a little bit better. Let's take a look at this one. Remember, this is the directrix, and this is the focus. Right, we're focusing that, and then this is the vertex. So if I take any point, right here, put a point, black point. This distance here should be equal to this distance here. This distance here should be equal to this distance here. I can pick a point way out here. Oh, I can pick this point right here on the tip. And then this distance here is equal to that distance there. That's the definition. That's the definition of a parabola in focused directrix form. Let's talk about JoJo. JoJo was given the directrix y equals 2 and the focus 3, 5. She did a little math and discovered that the two distances, this is the easy part, between any point xy and the directrix, between the point xy and the directrix, and the point xy and the focus is as follows. Here's the hard one. So she did all the math for you. She sets the distance equal each other. Set the distance equal each other and verify that the equation turns out to be this. So what I'm telling you is this is the answer. You help JoJo by setting the distances equal to each other and verifying that that is in fact correct. So we're going to do y minus 2 is equal to the square root of x minus 3 squared plus y minus 5 squared. First thing we're going to do is get rid of that radical by squaring both sides. So on this side I get y minus 2 times y minus 2 is equal to, now the square root and the square cancel, so it's equal to x minus 3 times x minus 3 plus y minus 5 times y minus 5. Lots of places to take dumb mistakes, which is why you'll notice I'm going to give you the answer. So you know where you have to end up when you're done. Now, if you want to fast forward or you want to try this on your own and pause it, go through it. See if you can arrive at that answer. If you can't, see if you can find your mistake. Go back, scrub through so you can find your mistake. If I double distribute this part right here, I end up with y squared minus 4y plus 4. If I double distribute this, I get x squared minus 6x plus 9. And this right here, I get y squared minus 10y plus 25. Now, if you've done it correctly, the y squareds will cancel. They always do. We're going to add this 10y over. Because remember, we're trying to solve for y now. So I get 6y plus 4 equals x squared minus 6x. Now, these two I have to put together. 9 and 25. So plus 34. So 6y plus 4 equals x squared minus 6x plus 34. We're almost done. Lots of stuff and lots of places to make mistakes. Let's remind ourselves what we want to get. We're going to subtract 4. Subtract 4. So I get 6y equals x squared minus 6x plus 30. Divide by 6. Divide by 6. Now, you could leave it like this. You could leave it like this. Or you could say, okay, there's really a 1 here. So that's y equals 1 over 6x squared. In the middle, you have 6 over 6. Those cancel, so that's just minus x. And at the end here, you have 30 over 6, which is plus 5, which is what we wanted to get. Yay! All right, lots of examples coming, but some are different. In this now, this is like half the problem we just did. We did the really difficult part. We did the difficult part. This is the difficult part. So there's easy, hard, and difficult. Maybe I should say really hard. I don't know. So on this one, we're now going to go all the way. We're going to just do it from the beginning to the end. So I'll be right back. Okay, I'm going to walk you through this. I am going to walk you through this process. The step one, the easy. Step one. This is the easy. This is the distance from point to directrix. Well, I guess I should have step 0. Step 0 is to pick a point. Oh, our point is x comma y. It will always be x comma y because in my answer I need an x and y. So if I don't introduce an x and a y, I won't have an x and y for my answer. So every single time that you do one of these focus directrix questions, you need to pick an x and a y. Just x, y. So step one, easy, distance. So we're going to say distance is equal to, it's always y minus directrix. So in this case, distance is equal to y minus, be careful with signs, -2. So in this case, it's d equals y plus 2. That's the easy part. Maybe we'll call step 2 the medium part. Step 2. This is medium. Distance from point to focus. Now, in order to do this one, you have to use the distance formula. Here's my point. Here's my focus. I need to use the distance formula. So in this case, d is equal to the square root of x minus 3 squared plus y minus 2 squared. Excuse me. Now, step 4, we'll do in green because it's, or step 3. Well, step 3. Step 3 is so, it must be so hard. We're skipping right to step 4. Step 3 is the hard part. You're going to set the distances equal and solve for y. So we're going to set those two distances equal and we're going to solve for y. And I'll do this in black. Excuse me. So my first distance is right here. It's y plus 2. And my second distance is right here. It's the square root of x minus 3 squared plus y minus 2 squared. All right. Now, we set the distances equal each other. Now we got to get y all by itself. Well, in order to do that, you have to get rid of the radical. So we're going to square both sides. So I end up with y plus 2 times y plus 2 is equal to, now this square root and this square go away. I end up with x minus 3 times x minus 3 plus y minus 2 times y minus 2. You are going to become double distributing geniuses by the time I'm done with 3.9. So we're going to double distribute. Go to purple to do that. Over here, we end up with y squared plus 2y is plus 4y. Plus, and then 2 times 2 is just plus 4. X squared minus 3y and minus 3x and minus 3x is minus 6x plus 9. It's positive because it's negative times negative. Plus y squared minus 2y. Did I do that right? Yeah, I did that right. Should go back to my notes. Okay. minus 2y is minus 4y plus 4. It would be really bad if I made a tiny mistake on one of these and you'd be like, you're not too smart. All right, we're good. So if you did it correctly, the y squareds cancel. And I want all the y's on the left side. So we're going to add 4y. By the way, don't skip this one. This one's tough. So I end up with 8y plus 4 equals x squared minus 6x. Now I'm going to put these two together. Plus 13. We're almost done. We just got a couple more things to do. We're going to subtract 4. That's a 4. Subtract 4. And I end up with 8y equals x squared minus 6x plus 9. Final step is to divide by 8. Divide by 8. And I get, well, nothing really, like on the last one, things kind of nicely got rid of. So this is just x squared minus 6x plus 9 over 8. Now, if that 8 went evenly into the 6 and evenly in the 9, I would do that math. For example, I could write this as, remember there's a 1 here, 1/8 x squared minus 6 over 8x plus 9 over 8. I could write it like this, but I'm pretty sure, wow, this was the answer I gave you. Okay. We've got 3 more examples. They take a while to get through, but each problem is a little bit different. This one's different because I'm giving you focus and directrix. This one I gave you focus and directrix, but this one I didn't give you the directrix. And this one I didn't give you the directrix. So those are a little bit different as well. So stay with me, try the problem, see how you do. Make sure you get through at least 6 and 7, okay? Minimally. And if you're still confused, go do 8. All right, I'll be right back. Okay, I'm going to try to walk you through these again. Stay with me. Step 0, pick a point. X, y, because we need it for our equation. By the way, here's the answer. Do you notice there's a negative in front? It's going to be an upside down parabola. I'm going to show you after this one. Let me get my calculator up and running. I'm going to show you after this one how to check your answer. All right, so step 1. This is the distance between the point and the directrix. Step 1. So distance is equal to y minus -1, which is really just y plus 1. There's the first distance. That was easy. Step 2 is medium. It's the distance between the point, the focus, and the point. And medium, we have to use the distance formula. So we're going to do the square root of x minus 2 squared plus y minus, now be careful here, this is -5. I threw a little monkey wrench in there, squared. So this is your second distance. You have to be careful with negatives. Always, always, always be careful with negatives. All right, so let's keep moving. Step 3. This is the hard step. Set them equal and solve for y. So we're going to set them equal. Y plus 1 equals this big long thing. Now I'm going to simplify it a little bit. X minus 2 squared plus, now this really makes a plus here, doesn't it? Negative, negative makes a plus. So that's y plus 5 squared. Now, I set them equal to each other, and maybe we could call it step 3 and 4 if you want. And now there comes the really hard part. You have to solve for y. So to get rid of that radical, we square both sides. On the left side, I get y plus 1 times y plus 1 is equal to radical and square root cancel. X minus 2 times x minus 2, that's x minus 2 squared, plus y plus 5 times y plus 5. Sorry, this is driving me crazy. All right, now we become double distributing kings. Y squared plus y is plus 2y plus 1. Again, this is plus y and plus y. That makes plus 2y. And then these two multiply, give me 1. X squared minus 2x is minus 4x plus 4 plus y squared plus 5y, that's plus 10y plus 25. If everything's done correctly, the y squareds will cancel. Sometimes when you have a sideways parabola and another directrix, and your teacher might go there, the x squareds cancel, but we're not doing that. All right, so I need to solve for y. So what I want to do is I want to get all this stuff. I want to get y, but if you remember correctly, I hate it. See, I don't want to solve for y. I don't want to solve for negative y. I want to solve for positive y. Now watch what happens here. This is a positive 10y. Don't do this. If I subtract 10y and subtract 10y, I end up with negative 8y equals. And now that's going to cause me all kinds of problems. So I don't want to do that just yet. So here's what we're going to do. We are going to move this and put all the y's on this side. So our y, which is what we're solving for, is positive. That's what we want. So we're going to subtract 2y. So let's clean this up and see what we got. 1 is equal to x squared minus 4x plus 29 plus 8y. So I got my y's all in one place. So all of this stuff here needs to move over to that side. So we're going to subtract x squared, we're going to add 4x, and we're going to subtract 29. Well, the 29 is going to go with this. So what I end up with is negative x squared plus 4x minus 28 equals 8y. Now, just because I like writing it like this, I'm going to write 8y equals negative x squared. This does not, just because I move things around, they're still saying the same thing. 8y is equal to negative x squared plus 4x minus 28. That's okay. You know, I'm still saying that this is equal to this. All right. Final step then would be just to divide by 8. And I believe that's the answer I gave you. I hope. There it is. Now, I could have given it to you as this. Y equals negative 1/8 x squared plus 1/2 x minus 28 over 8. 1/2 is 4/8. Now, how am I going to check this? How do I check this? Very difficult to check. You could come over here to your graphing calculator and graph that thing, control division, and see if that, so you get negative, oops, forgot the negative, negative x squared plus 4x minus 28 all over 8. So it's an upside down parabola. There it is right there. Now, the vertex, the directrix they said was y equals negative 1. Let's see if that makes sense. So let's just tab and type in negative 1. Oops, tab. So there's our directrix. There's our vertex right there. And our focus was, so if we want to know what our vertex is, we go to Control T and we go down to our vertex, which is going to be, what is our vertex? What's the highest point? Negative 3? Negative 3.5. Highest point is negative 3. So it looks like our vertex is 2, negative 3. So our vertex is 2, negative 3. So if I was graphing this thing, y equals negative 1, we'll go here. And then the focus was 2, negative 5. 1, 2, negative 5, 1, 2, 3, 4, 5. Down here, this will be the focus. And we just found out our vertex was 2, negative 3. And I'll do that in red. 2, negative 3, that's right here. Is that right there in the middle? It's another kind of an easier way to find it. All right, I'm going to get to 7, but I got to take a quick break, and I'll be right back. So this one offers a slightly more complicated problem, which is why I wanted to make sure that you tried example number 7. The problem is I don't tell you what the directrix is. So I don't know what this is, but you have to find it because those are the steps involved. So I'm still going to pick a point xy. Okay, I got that. But I got to figure out what this focus, what my directrix is going to be. So what I'm going to do is I'm going to come over here and I'm going to draw a very quick sketch of what's going on here. I have a vertex 1, 1. Let me draw a little bit bigger. See if I can. So my vertex is 1, 1. That's my vertex. My focus is 1, 4. 1, 2, 3, 4. So my focus is right here. So that means this thing should look like this when I'm done, because it opens towards the focus. So what I got to do to find the directrix is say, okay, wait a second, this distance is 3. So to find the focus, I got to go down 3. 1, 2, 3. And there is the directrix. So the first step was to find y equals -2 as my directrix. Y equals -2. All right, now I can go through and do my steps. Step 1, easy. Step 1 is easy. The distance between the focus or the point and the directrix. Y minus. It's always y minus the directrix, which is -2. And this turns out to be y plus 2. There's our first distance. That's this step 1. Step 2 is medium. It's the distance between the point and the focus. That's the distance formula. Distance is equal to the square root of x minus 1 squared plus y minus 4 squared. So now I have their two distances. I have this distance and I have this distance. And we're going to set those equal to each other and solve for y. So that's kind of like step 3. Step 3 is set them equal to each other. So y plus 2 is equal to the square root of x minus 1 squared plus y minus 4 squared. So now we're doing exactly like we did for the last 3 problems. It's just that finding that directrix, which was difficult. So the next problem is even a little bit more difficult than this one. We're going to square both sides. Let's see if we can get that answer again. Square both sides. Again, right now you should pause it and go on and go. See if you can get to the answer. Or scrub through and see if you get the right answer. So this is going to be y plus 2 times y plus 2 is equal to, cancel, x minus 1 times x minus 1 plus y minus 4 times y minus 4. By the way, if you're really good at the double distributing, you can just do all that in your head and go right to this step. You know you're going to double distribute this. So you know that's going to be y squared plus 4y plus 4. You know you're going to double distribute this, which is just going to be x squared minus 2x plus 1. Remember, it's minus x. And then y squared minus 4y is minus 8y plus 16. If you did it correctly, the y squareds cancel. And I end up with, let's see, I want to get the y's on the right side, or left side, so I'm going to add 8y. So I end up with I want to make sure I don't... Where do I get the other problem? Oh, it's down here. Okay, I'm not going to get to it. So I end up with 12y plus 4 equals x squared minus 2x, and I got to put this 1 and this 16 together, so plus 17. Solve for y. Subtract 4. Subtract 4. So I get 12y equals x squared minus 2x plus 13. We're almost there, kids. Divide by 12. Divide by 12. And I get y equals x squared minus 2x plus 13 all over 12. Is that what I gave you? Hard to see. Come on. There it is. Yay! Whoa! Oh, this should be 13. Ah, that's embarrassing. Did that just not print? Ah, see, it didn't print. It's there. It just didn't print. Where'd it go? See, there it is. When I printed it to OneNote, every once in a while it drops off numbers. So it's there. Hopefully it's on yours as well. All right, one more to go. The last one's really hard. You may want to stay with me on this last one. I don't believe this answer is correct. Hopefully it's changed on yours. This is 8. I must have did a little bit of extra cut and paste here. This should be negative x squared minus 12x minus 44 over 8. So let's hope we come up with that answer. I'm not sure. I must have screwed up there somehow. Sorry about that there, kids. Let's see what we got. All right, so this one is a particularly nasty problem because I didn't give you the directrix. We're going to pick our point. Our point is going to be x comma y. So I can't even do easy step until I figure out what the directrix is. So I'm going to draw my axes. I'm going to draw my axes here. I'm going to use this little bit of information to find my directrix. All right, so let me draw my axes. Ooh, that's not a good place to put that. All right, so let's get my scale on there. -6. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. We're going to need probably all that stuff. All right, so we're going to plot this vertex. -6, -1. That's my vertex. It's either going to open up or it's going to open down. Not really sure which one yet, but it's going to do one of those two. What the heck? All right, so there's my vertex, -6, 1. -6, -1. And my focus is -6, -3. So because this is the focus and the parabola opens towards the focus, this is the direction of the parabola. So that means that the directrix has to be up here somewhere. So if I figure out that this distance here is 2 units, then I got to go 2 units this way, and that gives us our directrix of y equals 1. So now I know that the directrix is y equals 1. That's the one more difficult step of this problem, is trying to find that directrix. Okay, now we're ready to rock and roll. Step 1, easy. Distance between the directrix and the point. So we always do y minus the directrix, 1. There it is. That's it. Nothing even to clean up. Step 2 is medium. The distance between the focus and the point. So we're going to find the distance between these two things by using that distance formula again. So d is equal to the square root of x minus -6. Oh yeah, I got lots of negatives in here. I forgot about how hard this one is. Squared plus y minus negative 3 squared. Right, because these are both negative. When I subtract them off, it's really adding. All right, so here we go. Step 3 is to set the distances equal to each other. So y minus 1 is going to be equal. Now I'm going to clean this up slightly. X plus 6 squared plus y plus 3 squared. Just be careful with these double negatives. Anytime you have a negative, you got to be careful with it. All right, we're going to square both sides. And over here, I get y minus 1 times y minus 1. Again, if you know that's y squared minus 2y plus 1, write it. Is equal to x plus 6 times x plus 6. Again, if you know that's x squared plus 12x plus 36, write it. Plus y plus 3 times y plus 3. All right. Woo! Now we double distribute. We become double distributing queens or kings. Y squared minus 2y plus 1. Again, it's minus y, and then plus 1. X squared plus 12x plus 36. Again, it's 6x and 6x. That makes 12x plus the 36. And then y squared plus 6y plus 9. Plus 3y, and then there's the plus 9. Did you get to become a double distributing king and queen? All right, we're almost done now. The y squareds cancel. Uh-oh. If I bring this 6y over, that means I have negative y's. I do not want negative y's, Sam I am. So, we're going to bring this over. We're going to add 2y. And then we're going to clean up a little bit. So we got 1 equals. Being neat and staying organized is really key to getting these problems correct. Okay, kids? So stay neat, stay organized. Lots of different colored pens helps too. X squared plus 12x. And then we're going to combine the 36 and the 9. And that makes plus 45. Oh, plus 8y. Now, we got the 8y over here. That's what we want. And then all the other stuff, all of this stuff, has to go to the other side. It's a mess. So we're going to bring it over. So we're going to subtract x squared. Subtract x squared. We're going to subtract 12x. Subtract 12x. And we're going to subtract 45. And we're going to put that over here with this. Subtract 45. So what I end up with is negative x squared minus 12x minus 44, because 1 minus 45 is negative 44, equals 8y. Divide by 8, divide by 8. And our final answer, and I'll put it right here, is y equals negative x squared minus 12x minus 44 all over 8. Is that what I told you it was going to be? Oh, no, I told you it wasn't going to be this, right? There it is. We got it. And on yours, hopefully it'll match. On yours, in that box, should be the correct answer. And that's it, kids. That's all she wrote. Focus and direct, because I will tell you right now, if you are my student, there will definitely be one on the test. And I'm not walking you through those steps, so make sure that you do the homework correctly. All right, kids? Catch you on the flip side. Make sure you hit subscribe and you hit like. Okay, you may not have liked this video because it was kind of difficult, but you can still like me. Okay, you may not like me, and you may not, all right, whatever.